triangles, we're going to do the same. We're going to find the named ratios of sine and cosine, or those specific ratios. To do that, since we're referencing angle A, we need to have the opposite to angle A side. So we're going to need to use Pythagoras. So using Pythagoras, I'm going to solve for this unknown side. So again, in trig, we're going to use Pythagoras quite a bit because we are dealing with right angle triangles. So I'm going to have x squared is equal to, it's one of the shorter sides, so I'm going to subtract from the longest side, 15 squared minus 10 squared. So 225 minus 100. So x squared equals 125. So x works out to be plus minus 125. And since we're dealing with length, we'll just use 125. Okay, that's approximately 11 point something. Okay, so the sine ratio, so I'm just going to write this in here, square root of 125. And again, I really want you to work on using these exact values and not having to rely on the decimal values. So the sine ratio is going to be the opposite of angle A. So angle A, there's my opposite side, square root 125. And I compare that to the hypotenuse, which is the longest side. And again, if you need to do lots of practice to make sure that you're getting the right sides in the right order when you're doing these ratios. So I'm going to do square root 125 divided by 15. Okay, and the decimal value for this, and again, we want to use exact values when possible, but there are times where you're doing calculations of lengths, and we may need to know the decimal value for that. Okay, so the decimal value works out to 0.745. So the cosine of A is going to be the adjacent side of angle A. So there's angle A. The next side next to it is 10. The hypotenuse is always the longest side, and this works out to be 0.6 repeating, so I'm going to round that to 0.667. Here the third side, all three sides have been worked out for me. And so I'm just going to reference our angle A. There's angle A. Sine is going to be, again, the opposite. So square root 32, that's approximately 5 point something, over the hypotenuse is 9. Okay, so again, I'm going to work out the decimal. We do want to use the exact value of square root 32 over 9 when possible. The decimal value is 0.629, right around that. And then the cosine of angle A is going to be the adjacent side to angle A compared to the hypotenuse. And when we divide that, we end up with 0.7 repeating, so I'm going to round that to 0.778 for the third decimal. So that is those ratios, those specific ratios are just comparing those two sides. Okay, the sine is opposite hypotenuse, cosine is adjacent hypotenuse. That so katoa is very useful for remembering that. Again, if you practice and do examples in your homework, these become second nature. So there is still this issue of we have a ratio that describes the shape of the triangle, and we have an angle that describes the shape of the triangle, and we need to be able to go from one to the other. And we want to do this using our calculator, and we use our calculator function of sine to go from angle to ratio. So if I had the angle here, if I wanted to find the ratio, I would use my sine ratio or cos or tan ratios to find the ratios. Here that's not necessary because I already have the side length or ratio description of this triangle. So I don't need to get the ratio. I could work out the ratio from the picture. But let's say I want to now get the angle. I want to go the other way. I want to start with the ratio and I want to get the angle. So I have to figure out a way to do this. Well, there's no way to do this other than going to my calculator. So it looks like this. And I want you to start getting used to and understanding how the sine and the inverse sine are related to each other. So these are the inverse functions. They undo sine. So instead of taking an angle and finding the ratio, so having the output as my ratio like we do have here, so cosine, the answer to the cosine is a ratio. I want the answer to be an angle. Okay, so I need to do the opposite. So in this case here, I could write cosine of angle A is equal angle A over the hypotenuse. That's great. Okay, this is perfectly correct. However, I want to now work out the actual angle value that describes the same shape. So to do that, I need to rewrite this expression. So I know the ratio, so my input's going to be the ratio into my arc cos, or my inverse cosine function. And my answer now is going to be the angle. And I need to use my calculator because my calculator has this function. So I do second cosine of 4 divided by 5, and that's going to give me an angle value of 36. Looks like 869, so I'm going to round that to 87 degrees. So this angle is about 36.87 degrees. If this is the length of 4 and this is the length of 5. Okay, this isn't quite drawn to scale, but it's close enough, and it gives us an idea of the length and how the lengths give us shape, and also the angle gives us the same shape. And we use the arc cos to get the angle. Okay, if we started with the angle, we could get the ratio of the sides using cosine. Okay, but in this case, we already have the ratio of the sides.